Well, thank you for the intro, Chris. To everyone here, I'm Hailey Terrones and Territory Manager at Gateworks, but I am excited to be here and share a field application story with you all. So thanks for tuning in. It is truly a timely topic. Industrial automation is evolving faster than ever, and manufacturers are racing to modernize, integrate robotics and AI to the factory floor, and the global investments in this smarter factory technology is an all-time high. So everywhere we're turning, it's here. And the story that I'll tell you all is mostly about modernizing a factory using Gateworks SBCs, CODESYS, and the growing ecosystem of the technologies around them. So like in ignition SCADA, Wi-Fi, Halo, other secure connectivity, and edge intelligence. There we go. So before we dive in, I'll give you a quick introduction to Gateworks, just so you know where we are as a part of this ecosystem. We're a USA-based designer and manufacturer of industrial SBCs and also embedded wireless solutions. All of our products are designed and built in our factory in California under an ISO 9001 certified quality management system. So for about 30 years, Gateworks has supported customers across industrial automation, smart energy, smart transportation systems, and defense as well. So I'm not an engineer by title, but I do get to be surrounded by them, maybe individuals like yourselves, control engineers, system engineers, embedded engineers, everybody who wants to just build smarter, more connected, reliable systems. So you're all the people behind the technology, and that's why I get excited about our industry. Even if the factory and the future is full of robots and AI, I think it's still designed for people. So, and designed by people who know how to make them work together. And I'd like to think that the point isn't just about making more money, but to give us humans back time to ride bikes, play with our dogs, and spend less time fighting legacy systems. So let's talk about it. And let's talk about single board computers, connectivity, and edge intelligence, and how this is transforming industrial automation for us. So if you tuned in earlier and heard Christopher open for us this morning, we are the part of the open source flexible hardware. So this is the aspect of the system that you saw earlier this morning. These are single board computers, and this is what Gateworks does. Most popular family here, standard SBCs. And I'm not trying to sell you on SBCs. I just want you to see where we fit in this system here. And we are providing customers with these as a long life Linux-based CODESYS ready computing platform. And they're all powered by NXP CPUs and security elements all made here in the USA. So a lot of wired and wireless flexibility. So our largest SBC that you see on the left here has 6 Ethernet ports and 4 sockets for wireless as well. Oops. Oop, there we go. This scales down to our most compact SBC with 1 Ethernet port, 1 mini PCIe socket for a radio or modem. In addition to these off-the-shelf SBCs, though, we do offer extensive customization, which most customers end up needing. But the engineers that are part of designing these boards are also the ones that are supporting customers through this evaluation. So the story I'll tell you today, our engineers did work hand in hand with them to get up and running. And we work closely with some of the best technology companies. So CODESYS, NXP, Telit, Morse Micro, uBlock, Silex, all of these guys. So at the end of the day, we just want to give everybody that is designing systems a faster to market solution and be able to have some confidence that they'll perform reliably for 15 years. So industrial automation, it's in the middle of this massive transformation. AI, robotics, OT, and IT are converging, cloud and edge computing are meeting in the middle, and manufacturers are racing to modernize. So whether you're an engineer or a part of the business development team, you're probably feeling similar pressures, shorter development cycles, legacy systems hitting EOL, robotics integration, supply chain issues, workforce turnover, and the expectation for data visibility from factory floor to cloud. So this is where CODESYS has become a game changer for our customers. It's allowing companies to take advantage of the modern computing hardware like a Gateworks SBC, run PLC logic on a secure Linux-based platform that's flexible, customizable, and capable of hosting multiple edge services in parallel. So my goal is that you leave with a sense of what's possible using an open source tool, proven hardware, and strong partnerships. So to enable automation, it's not just functional, but intelligent, scalable, and secure. So agenda for us, and the story I'll share today is one that started with a company just looking to replace aging PLCs and ended with an intelligent network powered by CODESYS, Ignition, and Gateworks hardware to build a system that's ready for the future. So to understand where this fits, let's zoom out really quick, because the changes happening right now in 2025 are reshaping how these factories and connected operations are really being deployed. And it's being discussed everywhere. I think we've seen a lot of the headliners. Amazon recently announced it's now operating over 1 million active warehouse robots. Toyota continues to roll out next-gen automation cells using advanced vision systems and collaborative robotics. Business Insider noted that factories producing everyday goods like dog food and shampoo are adding AI robotics to cut defects. So it's just very mainstream and a big conversation here. And even major investors are betting on industrial automation, AI, and robotics. SoftBank's $5.4 billion acquisition of ABB's robotics arm just came out a couple of days ago. And it's really not just a business deal, it's a signal for what's coming here. Okay, so first trend here is that many facilities are still running equipment that is 15 to 25 years old. Maybe they're rock solid and have been performing for decades, but they do come with limitations, limited I/O, scalability, proprietary programming tools, and potentially little integration with modern data systems. Replacement cycles that used to happen every 10 years are now stretching to 20 or more, simply because replacing the entire system control network is expensive and disruptive. So we're hitting a point where it's not optional. Parts are going obsolete, support contracts are ending, tariffs are potentially impacting the bottom line, and new production lines require more connectivity, flexibility, maybe machine learning that traditional PLCs weren't initially designed for. So this is where soft PLC platforms like CODESYS enter the picture for our customers. They're letting engineers run industrial-grade control logic on standard open hardware, like a Gateworks SBC, without being locked into some proprietary ecosystem. But instead of ripping out and replacing everything, integrators are modernizing. They're dropping in a CODESYS node at the edge, using the same ladder logic or structured text they already know, and then they can start bridging real-time control data up into Ignition SCADA or the cloud. So another force here accelerating the shift is a workforce transition. Deloitte posted that 2.1 million manufacturing jobs could go unfilled by 2030 due to skill gaps. Experienced automation engineers are retiring faster than they're being replaced. New engineers entering the field are fluent in languages like Linux and Python, Docker, but not necessarily closed PLC programming environments. And CODESYS is bridging that gap for us. So this is why I would assume a lot of people are tuning into a CODESYS Tech Talk like this week. This is also a big reason why companies are rethinking hardware. They want something that is future-proof, something that can speak both to traditional automation teams and to the newer digital engineer. And this is where our hardware fits in that puzzle. We're built with, low power, high performing NXP processors. They're running secure Linux distributions and can support Ethernet, serial cellular, Wi-Fi, and industrial I/O. So this is what's making them that bridge between generations of engineers and generations of technology. So a third piece here is connectivity and the expectation that everything from a motor controller to a remote sensor should be visible and manageable from anywhere. So this visibility brings challenges, network reliability, cybersecurity. Factories are connecting devices using Ethernet, Wi-Fi, cellular, long-range standards like Wi-Fi Halo, but connecting everything also creates a risk here, and everything connected must be secure. So that's why modern platforms are being designed with security built in to the hardware, but because you have to have a hardware-rooted approach to security. So this is how plants are ensuring that they can be connected, but they don't have to trade safety. And it appears that CODESYS is moving in that same direction, which is great, evolving its security hub and the architecture to make secure, standard compliant control easier to deploy across the entire network. So finally, the shift in edge intelligence is transforming how we're thinking about automation architecture entirely. Instead of sending data to a cloud, companies are processing it locally where it's generated. So with processors like NXP, we're using their IMX8M Plus. Gateworks SBCs can run real-time CODESYS control, ignition SCADA visualization, and even AI-based analytics on the same solution. So that's the opportunity, combining control, connectivity, and intelligence in just one small device, and it can be deployed anywhere. So maybe it's inside of a control cabinet or in a autonomous mobile robotic roaming around a factory. So all these forces, aging hardware, shifting workforce, connectivity demands, cybersecurity, AI, this is all setting the stage for us. CODESYS is giving engineers the ability to design real-time control on open hardware. And when paired with platforms like Ignition SCADA, it allows companies to have visibility, automation, predictive insight across every layer of their operation. And we're seeing this transition where companies are demanding modular systems that are capable of running both real-time control and edge analytics side by side. So this is the environment where the field application story is going to begin for us. The factory journey to modernize using CODESYS on a Gateworks SBC and to lay the foundation for future-ready automation and connectivity and edge intelligence. So let's get into it. So we had a customer that came to us with a challenge. They were running a mid-sized factory operation, multiple control panels and PLCs, some of them over 20 years old. The system was reliable but rigid. They wanted to start integrating more sensors, get real-time data into their Ignition SCADA dashboards, and eventually push analytics to the cloud. But existing PLCs were reaching end of life. Tariffs were making their current vendor less appealing, not to mention often on back order. And worse, each PLC ran proprietary code. So if one failed, only a specific engineer with the right license and the right legacy software could fix it. And they didn't want to completely reinvent the architecture, but they did want a path forward that was more modern and could future-proof them. So we started with a test. We began by replacing a single PLC with a Gateworks Venice SBC powered by the IMX8M Mini. Side note here, for those curious about trying this, we have documented everything that you would need to know about getting CODESYS up and running on a Gateworks SBC on our wiki. At the end of this, I have a slide with all the references that I've mentioned, and it's linked there. So you could have access to it and the breakdown of getting this up and running. So this board runs a secure Linux environment. It's built for industrial temperatures, 24/7 uptime. It's compact, fanless, and designed to operate in a rugged space. So our customer installed CODESYS runtime on the board, turning it into a soft PLC. And I think we have a software-based programmable logic controller. So it could execute the same ladder logic, structured text, and function blocks that engineers were already familiar with. So in CODESYS, they recreated the existing control logic, starting simple, reading digital inputs from push buttons, toggling outputs to drive LEDs and relays, and managing a few Modbus connected I/O devices. The next layer was visibility. So they connected another Venice SBC acting as the Ignition SCADA server over Modbus TCP, allowing the operators to see and interact with live process data from their control room dashboard. So this is where the flexibility of CODESYS shines for them. It natively supports industrial protocols like Modbus, EtherCAT, etc. So bridging between control and visualization is seamless. For the operators, the experience didn't change much. They still had the same dashboard and controls, but under the hood, everything was now running on an open Linux-based system that could be easily updated, backed up, and scaled. So one of their biggest concerns with this migration was real-time determinism. Could a software PLC really react fast enough to replace a traditional hardware controller? So we validated performance and security features that I'll outline later for us. The performance comes from the combination of the architecture of the platform and the CODESYS runtime's deterministic scheduling. So this isn't just a Linux box pretending to be a PLC. It's industrial grade computing designed to run deterministic control alongside edge intelligence. So they also implemented standard industrial safety measures, a watchdog timer to automatically recover from unexpected conditions, a secure boot sequence to ensure that only signed, verified firmware can run, automatic restart scripts in Linux to maintain uptime if power is lost. And the result was a platform that matched the reliability of traditional PLCs, but with the added flexibility of the software. So the real business value for them, though, was that when they were updating the old PLCs, they had to have a licensed Windows machine, special cables, vendor software, and now with a CODESYS soft PLC, updates could be pushed directly through the network or via remote secure access. And because it's Linux-based, engineers could use standard DevOps practices, version control, remote monitoring, and containerization, so something that's simply not possible on all closed PLC hardware. And since the Gateworks SBC is modular, the same system could scale. So add Wi-Fi for long range, wireless, drop in a Telit modem for 4G, 5G, RedCap, backhaul. This ability to scale made it ideal for large operations. Think multiple plants or multiple field sites, all connected over secure networks. So after running for months, the new system proved stable and also more flexible. The maintenance engineers loved it because they could log in securely and see diagnostics remotely. Operators loved it because the interface didn't change. Management loved it because the cost of ownership went down, fewer licenses, faster updates, no vendor lock-in. Supply chain management loved it because when they needed to buy more hardware, they could depend on us and our consistent lead times and pricing. So most importantly, the pilot became a template for their future expansion. So within 6 months, the customer rolled out the same CODESYS PLC configuration to other areas in the factory, all running on Gateworks Venice SBCs and all standardized under one open software ecosystem. So that is what modernization looks like in practice. Incremental, secure, forward compatible. And it's not just about replacing old PLCs. It's about redefining that architecture to support the future capabilities like wireless connectivity and AI at the edge. So let's also talk about how the same platform evolved from a wired control system into a more connected automation network using Wi-Fi, Halo, and cellular, giving engineers real-time visibility across remote distributed assets. So once the factory's new CODESYS-based control architecture was proven stable, the team's next goal was connectivity. They wanted visibility, not just from the control room, but from anywhere. They wanted to collect machine data in real time, access diagnostics remotely, and expand the system without pulling miles of cable. So that's where wireless automation became the next frontier for them. A traditional PLC network depends heavily on wired Ethernet, right, or serial buses. Reliable, but can be rigid. Each new device means new wiring, downtime, and for small retrofits or distributed assets, that becomes kind of costly and slow. Our customer had several secondary process areas, pumps, tanks, and stations in a metal walled room where running Ethernet was kind of impractical. So they wanted to evaluate Wi-Fi Halo, and they did that using one of our plug-and-play M.2 cards powered by Morse Micro's Wi-Fi Halo technology. And just for the sake of the group, if we haven't had experience with Wi-Fi Halo yet, it is still built on the 802.11h standard, and it operates in a sub-gigahertz band. So that's long range, excellent penetration through walls and machinery, and much lower power draw than conventional Wi-Fi. And it's been pretty ideal for industrial IoT and backhaul. But how did it work here? So they configured an SBC as a local Halo access point, running CODESYS software, soft PLC to coordinate several remote I/O nodes, each also equipped with a Halo interface, and the nodes collected temperature, vibration, pressure data, reported via Modbus over Halo. So upstream, the same SBC relayed aggregated data to the Ignition SCADA server through Ethernet. And this hybrid wireless approach gave the best of both worlds for them. So deterministic local control via CODESYS and flexible wireless connectivity for expansion. Whoop. Sorry, my screen went black. But because Halo does support kilometer scale links and hundreds of clients, the factory could now extend monitoring to outdoor equipment, remote storage tanks without trenching cables or installing repeaters. But anytime we move from wired to wireless, reliability and security are still top of mind, right? So this is where the hardware advantages, for example, NXP has an edge lock device that's a secure element, which made a real difference for them. Each wireless node established a mutual authentication handshake using stored keys protected in hardware. The traffic between the CODESYS controller and the remote devices were encrypted using TLS. Combined with the VPN tunneling for external access, this could create an end-to-end, more secure control loop. So this network delivered stable, low latency performance, even in RF noisy industrial environments. Throughput was more than enough for Modbus telemetry and control signals. But to make the system even more resilient, they added cellular. And in this system that you see, it's actually an M.2 based on Telit CMB 100 modem. And this provided a few benefits for them. So now they could securely log into the CODESYS soft PLC from offsite through a VPN, monitor logs, and push updates. And if the wired Ethernet connection went down, the cellular link carried essential telemetry to the Ignition SCADA server and the cloud dashboard. So the dual path design turned an isolated control system into more fully connected edge gateway, and it's capable of both local control and the remote management that they needed. So the new wireless network delivered an immediate ROI for them. The installation time dropped from weeks to hours. Maintenance teams could troubleshoot from their desks or from home, and the company gained some real-time visibility. So they did have a successful deployment, and it laid the groundwork for scalability for them. And the same SBC could later outfit with additional wireless if they wanted, 5G, Bluetooth, LoRa, all without changing the controller or rewriting logic. So this doesn't replace deterministic control, it's just extending it. And by integrating Wi-Fi Halo and cellular into a CODESYS soft PLC architecture, the factory could evolve from a collection of maybe wired islands into a more cohesive, connected automation network. So still secure, still deterministic, but now flexible, modular, and more future ready. So once the factory had that reliable connected control in place, the next question came pretty immediately. So now that we're collecting all this data, what can we do with it? So our conversation shifted from automation to intelligence. Most aren't training massive AI models, but more edge inference lets us run our existing data into insights. So they weren't just interested in turning things on and off. They wanted to understand more how their machines were behaving, why failures were happening, and if they could intervene before a problem caused downtime. So in other words, predictive maintenance. Many maintenance strategies include waiting for something to fail, then fixing it. But obviously unplanned downtime is expensive, and every minute a line is down is costing productivity, and this is disrupting. So their new goal was to detect abnormal patterns before a breakdown occurred. Vibration spikes, temperature drifts, motor current fluctuations, and they wanted to do it locally, so without relying on cloud analytics or an internet connection. So this is where the power of the system came in. The processor on one of our SBCs includes a built-in neural processing unit. So it has a built-in NPU, and this is NXP's IMX8M Plus. And it gets up to 2.3 TOPS of performance. So this means that it can run AI directly on the device without servers required. But a note here that some systems do require more TOPS than this, which at that point you would need to implement an AI accelerator. And you could do that on an M.2 or a mini PCIe card. So that could also be used if you needed more. I can share some resources and documentation for that as well. We have validated a couple different AI accelerators in this type of system. So, but the beauty of this is that it didn't require replacing the existing architecture. So the CODESYS continued handling the real-time control loop, managing the I/O, the ladder logic, the process control, and while a more lightweight Linux service ran alongside it to handle data logging and inference. So the CODESYS collected 5 sensor readings: vibration, temperature, pressure, from Modbus devices at second intervals. The values were written to a shared data file to a Python service. Python script fed that data into a pre-trained AI model deployed on the NPU. And if the AI model detected an anomaly, say a vibration pattern that indicated bearing wear, it would publish an alert back into the CODESYS environment or directly through Ignition SCADA. So the result here was a more closed loop between control and intelligence. A machine learning model is helping guide the very process that generates the data. So the data behind it was intentionally lightweight. The factory didn't need a huge data science team or expensive compute clusters. They started by logging just a few weeks of, quote, normal vibration and temperature data from each motor. And that data set was used to train a baseline model. Essentially, this is what healthy looks like. So during operation, the edge device continuously compared new readings to that baseline, and any significant deviation would trigger an alert. There's probably a few things I should tell you about that more. But during operation, the edge device was just continuously comparing new readings to the baseline. So because it ran locally, so the latency was near zero, bandwidth minimal, no sensitive data ever left the actual factory floor. So within a few months, the system could detect multiple early stage issues that traditional monitoring would have missed. One motor, for example, exhibited a subtle vibration pattern consistent with a bearing starting to loosen. Another pump showed a temperature trend increasing slowly over a few days, but because they had a system in place here, both cases, the maintenance team was able to intervene. They were able to prevent unscheduled shutdowns that would have cost thousands of dollars if they lost that throughput. So they began to trust the data. Maintenance went from reactive firefighting, you could say, to a more planned optimization. But because this all ran on the same system, the same SBC that already powered their control and SCADA connectivity, it didn't require adding a ton of new hardware. It was just another new layer of software intelligence. So this introduces a new kind of responsibility, security and performance, right? So the secure element played a key role here on the device that ensures that the AI model and the inference scripts were cryptographically signed, protecting against tampering. Secure boot as well can prevent unauthorized software from running, and hardware encryption kept log data safe. So even with AI processing enabled, the Venice board maintained deterministic performance on its CODESYS tasks, didn't miss cycles or have I/O jitter, but providing that intelligence, control, and real-time visibility can coexist on one SBC, one device. What started as a pilot for them in a production line soon expanded because the logic and the framework here was as simple as cloning and configuration. So that's where we see the power of combining this CODESYS soft PLC Linux and edge hardware, because you can start small, scale fast, and still maintain security. So the biggest shift here wasn't entirely technical. It was really engineers and operators beginning to see the controller not just as a tool for automation, but it could be a platform for intelligence for them. And with CODESYS managing control, Ignition providing visibility, and Gateworks hardware hosting that secure processing, the factory transformed from reactive to proactive. So you could say automation to more autonomy. Real-time control, secure wireless connectivity, edge intelligence, all within the system. But to keep it running 24/7 in a more harsh environment, they did have to ensure that it was secure, reliable, and built to last here. So this is kind of where that industrial DNA of the platform comes through. How long will the system last? Can it survive temperature extremes, dust, vibration, power fluctuations? Can it run for a decade? You heard earlier how security and reliability were a part of, design philosophy but this is kind of how it plays out in practice. So hardware can be built for industrial environments. For example, it shouldn't be consumer electronics just adapted for factories, but purpose-built embedded systems. But I'm not here, to sell you Gateworks products. We are just one option for an open source USA-made option. And a few things to look out for, though, when selecting hardware beyond that open source nature is going to be industrial rated components. So, -40 to +85 degrees Celsius, for example, maybe conformal coating, solid state storage, anything to ensure just durability in that dusty, vibration heavy setting. So very similar to the manufacturing floor. Reliability also comes from that supply chain aspect, long product life cycles. And once a system is validated, customers do need consistency for the next decade, not a redesign every 2 years because some part went obsolete. So when you connect controllers to networks, you truly expand capability, but you also expand the attack surface. So reliability and security come together here. And this is where hardware-based security can also become essential. So one example of hardware that we implemented was NXP's EdgeLock, and the secure element provides a hardware root of trust. So what that means is secure boot to ensure only authenticated firmware runs, encrypted key storage, keeping credentials safe even if the hardware is accessed, FIPS 140-3 ready protection. So this is aligning with more government and defense grade cybersecurity standards. And then TLS VPN acceleration for encrypted Modbus and SCADA communications. So in short, that same device that runs control logic can also enforce its own cybersecurity policies automatically in the hardware. So whether you're running CODESYS, soft PLC logic, ignition, SCADA, data collection, or AI at the edge, every layer of the stack can be protected from bootloader to application. So because CODESYS runs on Linux, customers can use secure update frameworks like OTA packages or Git-based version control to deploy new logic remotely. This was a major win for our field customer. They could roll out firmware updates, patch security, or features across multiple remote sites without physical access, all protected by cryptographic validation. So this can reduce service trips, speed up deployment, keep systems current, all without compromising the uptime. But this field deployment we've been discussing has now been running continuously for over 18 months. In that time, the system logged 0 unplanned downtime attributed to our SBC. The watchdog timers, redundant network paths, and secure firmware updates have kept everything operational, even through unexpected power interruptions. Operators reported that they've gone from reactive to more proactive monitoring, and that the combination of hardware reliability, secure architecture, and that open software has created one of the most stable platforms that they've ever managed. So as their industrial operations expand, these edge devices will form really the backbone of the connected factory, the smarter infrastructure, and more autonomous systems. So each controller is becoming that trusted node and a combination of rugged hardware, secure firmware, and that flexible software that can evolve with them. So what began as a single test to replace an aging PLC evolved into a more connected, intelligent, secure automation platform, and it bridged traditional control with modern edge computing. So every deployment has its technical challenges, right? And this project delivered a set of lessons that apply to other organizations modernizing their industrial systems. Switch. There we go. So we don't have to rip out and replace everything to modernize. For this factory, success started small with just one SBC running CODESYS, and it was a pilot project that mirrored existing logic but added flexibility and data visibility. And once that was proven, expansion came naturally. So this approach minimized risk for them. It preserved existing investments, built internal confidence, and it was a model that other integrators or plant managers can replicate, start small, validate performance, and then scale from there. So using open standards-based tools like CODESYS and Linux gave the engineering team the flexibility that they hadn't had before. They could integrate Modbus, MQTT all seamlessly, and they could edit code with familiar tools, and they weren't locked into some proprietary vendor ecosystem. So the flexibility pays off in speed and in cost savings. For example, when they wanted to evaluate a new technology like Wi-Fi Halo, or when they wanted to add cellular, they didn't have to change their logic. They just expanded the hardware and adjusted the network settings. The open system, it accelerates innovation because they let you adapt. So whether that's connecting new sensors, pushing firmware updates, or implementing AI analytics down the line, this is just what engineers love about open source hardware. It's not just rugged, configurable, flexible, and built for that further integration. So security and reliability here also go hand in hand. They strengthen each other. So when your system boots securely, runs validated firmware and communicates over encrypted channels, you can reduce that risk of failure. Hardware-rooted security, it doesn't just protect against cyber threats. It can enhance uptime by ensuring software integrity and configuration consistency. So engineers don't have to choose between being open and being secure. They can have both. And the edge is where this intelligence meets action, and where open tools like CODESYS lets engineers move faster than ever. Adding predictive maintenance wasn't a major infrastructure change. It was just another service running alongside the CODESYS PLC. And this is the power of that edge computing. When your controller becomes a mini computer capable of running AI, Python scripts, etc., your automation system evolves from that reactive to more proactive system. And that doesn't just improve efficiency, it can build that resilience within the factory. And every time a control catches a failure before it happens, that's the value that we see. Less downtime, fewer lost batches, better safety for workers as well. And finally, none of this is going to happen in isolation. We're just one piece of a very large puzzle. The success of this deployment was built on partnership. It was between our customer, the integrator, the ecosystem around Gateworks, like everyone here in CODESYS, NXP for the processing and security, the wireless connectivity aspect from companies like Silex or Morse Micro, Telit for cellular. So that's a big part of how we operate. We're not just shipping boards, we're helping customers build these systems that they can have for many years to come. So everything for our customer here, downtime reduction, early fault detection, faster troubleshooting, reduced unplanned downtime, deployment speed, adding new sensor nodes that can take hours instead of days, maintenance savings, remote diagnostics, cut site visits, system longevity, standardized hardware and open software can mean fewer redesigns and easier updates. And just as important, the engineering team gained ownership of their system again. So they weren't dependent on a single vendor for code access or updates. They controlled their own destiny here. So really the story is about how industrial automation is no longer about isolated control boxes or fixed logic. It's really about the connected, more intelligent and secure systems that evolve with your business. The combination of the CODESYS software, Gateworks hardware, and NXP technology is a roadmap for just how to get there. And it's a story about a factory modernizing control systems, integrating wireless, deploying AI, but it's really just about what's possible when everybody has a shared vision for that smarter, more connected, more resilient automation. So the factory truly achieved just taking systems that served them well for decades and evolve them into something a little bit more flexible, data-driven architectures that can meet some of the challenges for the future that they see ahead. So looking ahead, the next decade of industrial progress won't be defined by one single technology, but how securely we work together. CODESYS, Ignition SCADA, Gateworks hardware, the convergence is really what's enabling faster decisions, safer, more sustainable systems. I promise this is the last slide. But behind every automation breakthrough, there are people who make it happen. The engineers, the integrators, the operators, and even as the technology is evolving, it's really that collaboration between these people that will drive the progress. So if there's one thing I hope you take away, it's that modernization is within reach for every operation. We don't need Amazon-sized budgets or Toyota robotics labs, just reliable, secure platforms and the right partners. So if you're managing a production line, industrial network, or launching a new product, I hope this story inspires you and helps you see what is possible with this type of integration. And I will share these references with you as well. I have a couple that I can get in front of everybody and the links to everything that we talked about. But that is all for us. If you'd like to learn more about Gateworks, you know where to find us. And I appreciate you spending the time with me today. And I look forward to hearing more questions and feedback and everybody else that's presenting. Thanks, Chris.
Yeah, Hailey, that was one of the most impressive application stories, to be honest. I hear it excellent. Because it went from A to Z in an automation engineer. So I just have to repeat two sentences you brought up. CODESYS built the bridge between generations of engineers and generations of technology. I loved this sentence. And another one.
Feel it, it's yours.
Thank you. And the other one, to make it secure, we go cellular. That was also something very, very interesting you brought up. Yeah, thank you very much, Hailey.
Yes, you're welcome.
Thank you, Gateworks, for the exciting look at edge automation and this impressive application story.
Yes, more to come. Thank you.